Hey guys, Justine here from Compass Maths Tutoring, and today's topic is about arcs, sectors and segments. And once again, this is another 2-unit topic, and we're going to be looking at them in their formulas and just going to be quickly going through the ways that students can misunderstand or misinterpret the question and not sub in the values correct into the formula. Okay, so just really quickly here, we're going to start with the formula for the arc length. So the formula for the arc length is equal to r theta. So what's important to understand is that r represents the radius and theta represents the angle, but it's important for you to understand that it's the angle in radians, okay? So this is something that students tend to forget, but it can cost you quite a few marks. So just remember that this angle is in radians, not in degrees. So in saying that, when you are given an angle in degrees or asked to find the angle, then you need to convert between radians and degrees. So just keep that in mind. And then the area of a sector. So the area of a sector is half r squared theta. So once again, r represents the radius of the circle and theta is the angle subtended at the center in radians, okay? And then the area for a segment is half r squared theta minus sine theta. So they're really simple formulas to work with. It's just one really key important rule that your angle is always in radians, not in degrees. So we'll look at the first example. So it says, find correct to the nearest square meter, that's important, the area of a sector of a circle of radius 100 meters if the angle at the center is 100 degrees. So we're finding the area of a sector. So that's this formula over here. So area of a sector equals half r squared theta. Really easy. So, you know, you go your r squared, it's here, your radius is here. But you look for your angle and it says the angle is 100 degrees. So like I said previously, we can't use this angle in degrees, but rather in radians. So what we need to do is convert this angle to radians. So to convert between, where should I write this? So to convert between, or to go from degrees to radians, you must multiply by pi over 180. So what that means is that to convert this 100 degrees to radians, you must do 100 times pi over 180. And what you're left with is 5 pi over 9. So those cancel, and you can divide these each by 2, and you're left with that. So this is now our angle in radians, and so we can simply sub it into the formula now. So A equals half times r squared, and r we said was 100 squared, times our theta, which is now 5 pi on 9. So I'm going to plug that into my calculator and I'm going to round to the nearest square meter. So we get 8,727 meters. Pretty easy, huh? You just need to understand that your angle is always in radians, never in degrees. We'll look at one quick last example. So it says here, an arc of a circle of radius 7.2 centimeters is 10.6 centimeters in length. Find the angle subtended at the center by this arc, correct to the nearest degree. So what are we finding? An arc of a circle of radius, so the radius is 7.2, is 10.6 centimeters in length. So that's the arc length. So the length is 10.6 centimeters. So we know the formula for the arc length, if you recall from the previous page, is given by r times theta. So what we need to do here is find theta. So I'm going to rearrange this formula to make theta the subject. So it's theta equals length over the radius. And now we just substitute our values in. So we get length of the arc is 10.6 centimeters. We divide that by the radius, which is 7.2, and we get 1.47 rad. Remember, we find it in radians. So what must we do now? We look at the question and it asks to find it to the nearest degree. So we're not quite there yet, but to convert, so now we have to convert, from radians to degrees. So to convert from radians to degrees, you just simply do the opposite. So before, to convert from degrees to radians, we multiplied by pi on 180. But to convert between radians to degrees, we multiply by 180 over pi. So then we multiply this by 180 over pi and we get our angle. So it's 84 degrees to the nearest degree. And then we have it. Really simple formulas, but something students tend to trip out on is not knowing whether to use radians or degrees. And it's always radians, unless the question asks to find it in degrees, like this question did to find it in degrees, but we still obtained our answer in radians. And then from there, we convert to degrees. Or if the question is given to you in degrees, you always need to make sure that you convert that. So I hope that helps.